Hey, good afternoon, everybody. I'm back again. There's a request for me to show you the work on 551, number 44, and number 46. On this video, I'm going to fully explain 44, and then I'm going to introduce some concepts you're going to use in 46. And I'm going to have a separate video for that because it's a long problem, and I'll need to use the whole space on the whiteboard. So going to 44. I don't have room here. This is just the left-hand side of the identity. Remember, you can't move anything across the equal sign. So I'm working fully on the left-hand side. So as you can see here and here, my next step, I'm going to use the sum formula for cosine. And then over here, I'm going to use the sum formula for sine. So that is right here, within the brackets. Remember, those formulas are on page 541 if you want to review them. So then what I'm going to do, going from my third step, is I'm going to distribute. Here. Okay. So since I'm multiplying cosine y by cosine y here, that becomes squared. And here I'll have three separate terms, a product of three separate terms. And then here, when I distribute this out to the first term here, this product here, I get three terms. And here, the sine y's are going to multiply them, so I'm going to get sine squared y. Okay, so as you see this step right here, these two, they're like terms with opposite signs, so they're going to cancel out. Then what I've underlined in red, this is what is left. I left out one step just to save some space. So these two terms, I factored out a cosine x, and I was left with cosine squared y plus sine squared y. Remember, this is one of your Pythagorean identities. So that is equal to 1. And 1 times cosine of x is cosine of x, and that's exactly what you wanted to prove. Okay. Now, going to 46. There are two concepts that I want to preview with you here. One is, this is not the problem here. This is actually the sum formula for tangent, which you're going to use within number 46. However, what is different is, you're not going to go left to right. You're going to go right to left. So I'm going to have to create this situation part of the problem so that I'm able to add angles here. Okay. Another concept that's involved is the odd function. The tangent is an odd function. All right, so here I have a simple example. If I'm taking the opposite of 45 degrees, that's my input, then the output becomes the opposite, so then the negative sign comes on the outside. So these are equivalent statements here. Now in number 46, what makes it different is they define the angle. For example, one angle is x minus z, like this. So what I want to do is I want to take the opposite of this. So that means these signs are going to change. So I'll write z first because it's positive and the x becomes negative. Now when I do that, since tangent is an odd function, if I take the opposite of the input, the output changes to its opposite. So that is an equivalent statement. So this idea, you're going to use, I think, twice within 46. So the problem is going to start with using this, going right to left on the sum formula of tangent. And I think, if I remember correctly, twice within the problem, we're going to have to use tangent as an odd function. Okay, so take a look at those, and then I'll be recording another video that shows all of 46.